So let's think about how we would need to do the dilution calculations to generate the standard solutions for our curve and our percent of copper and brass lab. We're starting out with a known concentration solution of copper 2 nitrate. We know that it is 0.400 molar. And we're going to dilute that to different concentrations to get the absorbance of those different concentrations. Now, as an example, I'm going to use what would happen if we needed 10 milliliters of 0.25 molar solution, which is not one of the ones that you need to calculate, because I want you to have to practice calculating all of them and not just have one already done for you. When we're doing a dilution, the thing we have to think about is that the only thing we add is water. So that means that the moles of copper nitrate that we start with has to be the same at the end. The molarity will change because the overall volume changes. Well, if we know that moles are equal to molarity times volume, then if all we add is water, the molarity times the volume at the beginning, or the moles at the beginning, will have to be equal to the moles at the end, or the molarity times the volume at the end. So looking at this particular problem, let's see how we can put this information into this formula. We start with a molarity of 0.4 molar. That's my M1. What did I start with? I end with a desired molarity of 0.250. That's going to be my M2. I know how much volume I want to have at the end. I want to have 10.00 milliliters of this 0.25 molar solution. So what I want to find out is how much 0.4 molar solution do I need to then add water to get to a total of 10 milliliters. And of course we write it, solve it, math it. M1 V1 equals M2 V2, our standard dilution equation. We're interested in V1, so if I solve that, that's M2 V2 over M1 is equal to V1. So now let's sub in our information. 0.250 molar times 10 milliliters divided by our known 0.400 molar. Notice my molarities cancel, so I have a V1 in milliliters, which makes sense. We were looking for a volume. So if I do this math and I plug it into a calculator, this tells me that I need 6.25 milliliters of 0.4 molar solution. So let's think about how this would look physically. So I'm more than likely going to do these in a test tube because there's not a huge volume of solution. So what I would start with is I would start by putting 6.25 milliliters of blue copper 2 nitrate solution into my test tube. And now I have to add water to get to a total volume of 10 milliliters. Well, if I want a total volume of 10 milliliters, then I'm going to take 10 milliliters minus the 6.25 milliliters of 0.4 molar solution I have in here to get me the milliliters of water I need to add. So I would add 3.75 milliliters of H2O to my 6.25 milliliters of 0.4 molar solution, because that will get me a total volume of 10 mils. And now I know that that molarity would be 0.250 molar. So that's how I'm going to do the dilution calculations, and you will do that for your samples.